In the previous lecture, we learned the method for parametric differentiation. We differentiated x, y, and then we differentiated y, and then we took the quotient and we simplified. That was simple. But Cambridge doesn't award A stars, right? For knowing formulas only, right? It awards A stars grades for knowing when to use them. Let's now solve the kind of questions that actually appear in P3. Now, when it says that find the tangent parallel to the x-axis, now suppose x is equal to t cube minus 3t and y is equal to t square plus 1. So dy by dx is going to be equal to dy by dt, which is 2t, and dx by dt, which is 3t square minus 3, right? Now, so this is the differential in terms of t. Now, what does parallel to the x-axis mean? Parallel to the x-axis mean that the gradient is 0, right? Because this is x-axis, and parallel to x-axis means that the gradient is 0, or dy by dx is going to be equal to 0. When dy by dx is going to be equal to 0, it can only happen when your t is 0, because 2t upon 3t square minus 3, which is dy by dx, when you equate it to 0, your t comes out to be 0. And when your t is 0, your x is going to be equal to 0 and your y is going to be equal to 1. So the coordinate at which it occurs at 0, 1, t is equal to 0, dy by dx is going to be equal to 0, and that's it, right? Now, for a fraction to be 0, the numerator has to be equal to 0, right? Now, so x is going to be equal to 0, y is going to be 1, and that's it. Now, this is why I kept saying that in my last lecture that don't memorize formulas, understand fractions. Now, let's do another question. Tangent parallel to the y-axis. If the tangent is parallel to the y-axis, it means what? That your gradient is undefined, right? Or the denominator is 0, right? Now, the tangent is vertical. When is a fraction undefined? It is when the denominator is 0. Therefore, the dx by dt, the denominator, is going to be equal to 0, right? Now, so we are going to differentiate. We are going to find we are going to differentiate it and equate it to 0. So 3t square minus 3 square minus 3 is going to be equal to 0. So this occurs at plus and minus 1, right? Now, when you substitute it, you are going to get two coordinates for x and y. So when t is going to be plus 1, so when t is going to be 1 and t is going to be negative 1, x and y. X is going to be at 1, this is going to be 1 minus 3 is minus 2. And y is going to be 1 plus 1 is 2, and when t is minus 1, this is going to be equal to 3 minus 1 is 2, and minus 1 is square, and this is 2. So minus 2 2 and 2 2, minus 2 2 and 2 2, these are the 2 points at which this curve is going to have vertical gradients, right? At t is going to be equal to, so this is at t equals to plus 1 and this is at t is equal to minus 1, right? That's it. Now, so whenever the gradient, or rather whenever the tangent is horizontal, dy by dt is 0. Whenever the tangent is vertical or parallel to the y-axis, then dx by dt is 0, right? This one observation appears repeatedly in Cambridge. Now, if you had to find the equation of a tangent for this very curve when t is equal to 2, so x is equal to t square plus 1, y is equal to 3t minus 2. So, and you have to find the equation of a tangent at t is equal to 2. So, at t is equal to 2, x is equal to 5 and y is equal to 4, right? So, the coordinate at which this tangent occurs on this curve is 5, 4. dy by dx is going to be equal to what? Dy by dx is going to be equal to dy by dt in the numerator, which is 3, and dx by dt in the denominator, which is 2t, and t is equal to 2, so this is 4. So the gradient is 3 upon 4. So just put it in point slope form. So y minus y1 is equal to m 3 upon 4 and x minus x1, which is 5. And this is your equation of the tangent. Now, so this is exactly like Cartesian curves. Nothing changes. The only new thing is finding the gradient, right? Now notice something. After you found dy by dx, everything becomes ordinary differentiation again. Tangents, normals, stationary points, increasing, decreasing, nothing changes. Now let's do a mixed trigonometry question. Let's do a question 4. Let's say x is equal to 2 cos t and y is equal to 3 sin t. You have to find dy by dx. So dy by dx is going to be equal to dy by dt, which is 3 cos t, and minus 2 sine t, which is dx by dt, right? If you had to find the equation at t is of the tangent at t is equal to pi upon 4, right? So at t is equal to pi upon 4, you put this here, so this becomes 3 over root 2 divided by this becomes minus 2 over root 2. So root 2 gets cancelled, so this is nothing but minus 3 upon 2. So students should now immediately know that they had to differentiate, divide, substitute, no elimination, and hence no panic. Now let's apply some more knowledge of our calculus, right? Now dy by dx is going to be equal to dy by dt, which is, so we apply the product rule here. So u v dash plus v u dash and dx by dt. So this is nothing but et. So you take et, so this gets cancelled. So your answer is going to be 2t cube. That's it. As simple as that. So can you see that every previous chapter connects? Now, so I can stretch this chapter for as long as I can. We can keep on doing examples after examples, but what I would recommend is that you go on your Cambridge endorsed textbook, you find out the exercise for parametric differentiation and you do all the questions from there, right? Now let's talk about marks, not mathematics, marks. These are the 5 biggest reasons Cambridge students lose marks. They first of all, so this is the first trap. They eliminate the parameter unnecessarily. So they will substitute it. So for example, if x is equal to t and y is equal to t square, so dy by dx is going to be equal to, so they will first make, so they will put this here, they will make y is equal to x square and dy by dx is going to be equal to 2x, and then they will put it back here. So this is going to be y equals to dy by dx equal to 2t, or they may just leave it here at dy by dx equal to 2x, which is not desired because y is not a function of x directly, right? They forget to apply the chain rule when they are differentiating sine t. Let's say y is equal to sine of 3t, they will put dy by dt is equal to cos 3t. Now this is wrong because you have to apply the chain rule and multiply it by the differential of the argument as well, of the inner function, right? And similar is the case when they are differentiating e to the power of 5t, right? And they will just rewrite it as e to the power of 5t without multiplying it by 5. When they don't do it, they lose marks. Now trap number 3 is they do the cancelling incorrectly. So students often cancel t when it shouldn't cancel. So sine 3t upon t, you cannot cancel these t's. This is horrible algebra. Don't do that. Now trap number 4 would be if you're finding dy by dt. If you're finding dy by dt and you forget to divide, half the question completed is just the half of the question that's completed. Half is forgotten because you have to find dx by dt as well, and then you have to divide dy by dt by dx by dt in order to get the chain rule dy by dx. So this is the complete form, right? So make sure that you do it complete. Now when they are in another trap that students fall into is whenever they are finding gradient, they never find the coordinates. So if t is given, you find out what this x occurs at x, whatever this value of t is, let's say t naught, and what is y at t naught, right? You get these values because let's say this is your x naught and y naught, right? And they occur at certain t naughts, right? So you find that and then only can you find the equation of the tangent. Now how does Cambridge think? This is something I wish more teachers explained. Cambridge isn't testing whether you remember that dy by dx is equal to dy by dt divided by dx by dt. I mean, Cambridge is not testing you on this. That's 1 mark. Cambridge is testing whether you recognize that x and y are both controlled by the same parameter t, another parameter, or theta sometimes in terms of trigonometry or something else. That's a real idea. So just to sum it all up, let's look back. 5 weeks ago we started with algebra, right? Algebra, we did under that, we did modulus, we did polynomial division, right? Long division, factor and remainder theorem as well. We did partial fractions as well. We did binomial expansion. Yeah, we did that as well. We covered that. There is a video on this as well in the playlist. Then we moved on to logarithms, then exponentials, then linearization. Then we moved to trigonometry. We did the identities under that. we did the R form, auxiliary angle form. We also did the trig equations as they test you in the exam. And then we started calculus. We did the product rule. We did the quotient rule. We did implicit differentiation. And today we completed the differentiation part of calculus after concluding parametric differentiation, right? So almost 65% of the P3 syllabus has been completed, and by 5th of August, exactly after 20 days or 18 days, we'll be done with our entire syllabus before we move on to S2. Now, today, you know every major differentiation technique in P3. Take a moment to appreciate how far you have come if you have been following. Now, the big picture is that many of you will think that math is lots of unrelated chapters. It's not. It's just one big story. Algebra helps logarithms. Okay. Now, logarithms helps differentiation. Integration helps differential equations, which we are going to come after we have done integration, and everything builds on everything else. That's why I teach this course in sequence. Now, what's next? Now, imagine someone gives you that dy by dx, the differential function is 6x squared. Now, today you know how to produce it. You can come to this result if you're given y. Now, but suppose I ask you something different. Can you reverse the process? Can you go backwards? Can you recover the original function? Can you come to what y is? Now, for an easy function like this, of course, you have done this in AS Math. But for something like 6 ln x, can you do that? No, of course not, right? So this is what you learn in integration, and that's exactly where we are going from Monday. Many students think integration is a new topic. It isn't. It's simply differentiation played backwards, right? So if you have understood everything we have done in this chapter so far, integration will suddenly make much more sense. Now, by the way, last week, wait a second. Last week, I uploaded a midterm assessment covering roughly 50% of the P3 syllabus we have completed together. It's on our Instagram. If you haven't attempted it yet, do it before watching the solution. I'll upload the complete walkthrough by Sunday after 2 days, right? You'll quickly identify which topics are already strong and which need more revision. So if you have watched this lecture from beginning to end, and you have also watched the first part of this parametric lecture, which is on the same playlist, congratulations. You have completed the entire differentiation series, right, of 9709/32 P3. From next week onwards, we begin the second half of calculus, that is integration. We are just left with 30 to 35% of the P3 syllabus, and in the next 20 days, we'll cover that as well. Now, after integration, we'll move on to numerical methods, vectors, and differential equations before we conclude everything into complex numbers. Just 4 topics left after integration, exactly as laid out in the P3 syllabus. So if today's lecture helped you, this is my CTA call to action. Don't forget to like the video. It helps other Cambridge students find it as well. Comment below differentiation complete, so I know you have reached this milestone. It also encourages me to keep producing more of such content. Share this lecture with a friend who's preparing for October, November 26 or May, June 27, right? And subscribe to the channel because the integration series starts on Monday, and each lecture builds directly on the previous one. For daily Cambridge Reels, examiner insights, save-worthy revision carousel posts, and structured study advice, follow Easy Taleem on our Instagram. We go there by the name of this handle, EASYTALEEM. And if you're looking for structured classes, recording, tests, or guidance through your A-level journey, message us on our WhatsApp, which is +92 329 3028 485. The classes are very affordable. Until Monday, keep practicing, keep questioning, and remember, don't memorize mathematics, understand it. That's what earns A grades. Allah Hafiz, and I'll see you guys in the next lecture on integration on Monday.